I hope everyone's doing well. I am Mr. Ish. Thank you for joining me. In this video, we're looking here at the synthesis of Motrin, ibuprofen, and analgesic, a pain medication which most people take. Starting here with benzene, we're going to do a Friedel-Crafts alkylation. We have to bring a item onto this benzene ring. And what is that item? Let's draw it out for you. You have CH3, you have CH, CH3, and then CH2Cl. This has to be added on. When you're looking at it, you have 1, 2, 3 carbons, you have one over here, you have over here 2-methyl, 1, 2, 3 propyl chloride. And because we're not mentioning a number here for the chlorine atom, it's assumed that it's attached to your first carbon, which is 1, 2, 3. 2-methyl propyl chloride, or you could have even said 1-chloro 2-methyl propane. 1-chloro 2-methyl propane. That's what you have. This is what we have to add onto our benzene ring in a Friedel-Crafts alkylation using that catalyst. This alkyl halide, in the presence of this Lewis acid, it will add on. When you add it on, you have this CH2, then you have CH, CH3, and CH3. We have 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons, and it looks good. That is our end result after adding this. And the abbreviated version would have looked something like this. This is exactly what we have. CH2Cl. We have 1, 2, 3, 4 carbons, and that's our end result. This has been done, a Friedel-Crafts alkylation reaction. Now what we have to do is bring something over here, and we will. What is that item we will bring over there? Acetyl chloride, CH3, C double bond O, Cl. In the presence again of a Lewis acid, because we are doing Friedel-Crafts acylation. Here we did alkylation, we did alkylation. Here we're doing an acylation. What's the difference? Here you're adding a carbonyl compound, here you're adding an alkyl compound. That's the only difference. Friedel-Crafts alkylation, Friedel-Crafts acylation, and we'll do it. This group we have over here, alkyl group, is an ortho-para director, so it'll more likely add para than ortho because of steric factors. It'll add over here. When you do that, this is what you have. You have this item over here, which I'm going to abbreviate it as this. It has been abbreviated for you. Now we've got here C double bond O, CH3. That's what we have. An acetylated benzene with that item here on the top. What we have to do now is get rid of this carbonyl group, and we will reduce the carbonyl group in the presence of sodium borohydride. It'll convert this into an alcohol. When we do that conversion, this is exactly what we'll have. We have this item over here. You can present this however else you want. I'm just doing the shortcut. Now let me make it a little more clear like this. You have 1, 2, 3, 4. At each of the junctions and at the points here, you'll always have a carbon. That's your 4. And this will get converted into an alcohol. You'll have a CH, CH3, and an OH. We've not lost anything other than we've reduced the carbonyl into an alcohol. Now what we have to do is get rid of this and convert it into something else. And what is that item we will do? I'm going to do a PBr3. Because I want to convert this into a bromine atom. I want to get rid of the hydroxyl group, and I want to bring this phosphorus tribromide and bring the Br in place of it. When I do that, that will be my step number 1. My step number 2 will be NaCN, because I'm going to do a nucleophilic substitution, sodium nitrile. We're going to put the Br over here, and then it will replace it with the CN. Why are we doing that? Because bromine is a better leaving group than hydroxyl. When you do the first step reaction with step number 1, as you see over here, this part right here will stay as is. What you're getting over here is a CH and a Br and then a CH3. That's what you have. The hydroxyl has been replaced to a bromine by PBr3 step. Step number 2, sodium cyanide, is going to bring it into CN. Sodium nitrile, sodium cyanide, you can say it either way. It's a nitrile functionality. And that's what we have. Step number 1, convert it into a bromine atom. Step number 2, bring the nitrile, and we are good. Our very last step to take it to our end product, and I'm designating my end product like that, and I'll show you what that product is at the end, is to oxidize this into a carboxylic functionality. We're going to convert it into a COOH. That nitrile will be converted into COH, and how do we do it? In the presence of acid and water. We are literally oxidizing it, and it will give us our end product, ibuprofen, which is Motrin. For the reaction to proceed in a better manner, you'll obviously have to put some heat in there, but this right here will convert into a carboxylic group, and we'll have our end result. Look at the gist of our reactions. We start here with benzene, we do a Friedel-Crafts alkylation, then we do a Friedel-Crafts acylation, we do a reduction here, converting to an alcohol, convert it into a bromine ring and a nucleophile nitrile, and oxidize it to our end result. Let's show you what our end result is. This item here is just being converted here into a carboxylic functionality, and that right there is your end result. But I'll show it to you over here in a better way. The benzene ring, the item we alkylated it using the Friedel-Crafts alkylation reaction. You had the CH2, as you can see right over here, CH, CH3, CH3. Over here we had our CH, a CH3, and our carboxyl group coming from the nitrile. And this right here is our Motrin compound, ibuprofen, and we are done. Have a good day.